That's why the power electronic converter will plays important role in the electric vehicles. Clear? For DC drives, the power electronic converters such as control rectifier or choppers, okay, can be used to adjust the DC power. In contrast, AC drives mostly use the inverter technology, means rectifiers and chopper. DC drives means DC drive is nothing but if we are using the DC motor, if we are using the DC motor, then the setup can be called as a DC drive. Clear? If we are using the AC motor, then that setup can be called as an AC drive. Is it clear? For example, if DC motor using, that is called as DC drive. It requires rectifier, control rectifier. Means control rectifier function क्या है? AC to DC convert होता है. और chopper का function क्या है? DC to DC. Clear? DC to DC. Accordingly, we need to develop the converter circuits. In case of AC drives, we are using the inverter circuit. Inverter means DC to AC. Okay, means simply what we can say. So accordingly, we have to, based on the drive, DC drive or AC drive, we need to use the converter circuits. We need to design the converter circuits. In that converter circuit, already we have discussed the power electronic converter use the power semiconductor devices such as GTO device, thyristors, IGBT or IGCT, MOSFET, okay, diodes, and so on, etc. Okay, number of devices are there here. These are the power semiconductor devices. These are the electronic part. Okay, electronic devices are called power semiconductor devices. So by using these power semiconductor devices, we are designing the converter. We are designing the converter, maybe a rectifier, inverter, maybe a chopper, maybe AC voltage controller. Clear? So by using these power semiconductor devices, we are designing the converter circuit. Clear? So when the devices should be turn on and turn off, maybe MOSFET is using 3 or 4 devices here using the converter. So for controlling the power, the device should be turn on and turn off. The device should be turn on and turn off. Okay. Then only the power will be controlled. So when the device is turn on and not turn off, then what will happening? The power will supply the continuously. The power will not be controlled. That's why whenever the power controlling is going on, definitely the devices should be turn on and turn off at proper intervals. At proper intervals. Clear? This is the simple, just for a brief idea. I have given this diagram how the AC to DC conversion is going on. Okay, because the mechanical students are not studying all these concepts. Okay, here this is the converter circuits. Is it clear? This is the converter circuit. Here we are using the thyristors 1, thyristor 2, 3, 4. T1, T2, T3, T4. These are the power semiconductor devices. So this is the converter circuit. And this is the supply AC. Okay, so how it will convert DC? See here, supply कौन सा यहाँ पे? AC. This is the supply voltage. AC means positive half cycle and negative half cycle. And next positive half cycle and negative half cycle. This is the supply voltage. This we are applying the converter. So here DC कैसे मिलता है अपन को? DC कैसे मिलता है? Thyristor will turn on by giving the gate pulse. Thyristor will be turned on by giving the gate pulse. When the thyristor is turned on, it will act as a closed switch. It will act as a closed switch. For example, I have given the gate pulse for T1 and T2 at a time. T1 and T2 at a time. Because for flowing the current, the circuit will be closed. Circuit close होने के लिए अपन को T1 और T2 on करना पड़ेगा. I am not going to depth. Just get an idea only. Clear? Positive half cycle में क्या होता है? This is the positive half cycle. This is the positive polarity. This is the negative polarity. Now the current will start from the in this terminal. Okay, through this terminal, and the gate pulse is applied for T1 and T2 at this point. At this point. Clear? This is the firing angle alpha. If at this interval I have given the gate pulse, then the T1, T2 will be turned on. when the T1, T2 will be turned on, it will act as a closed path. So it will act as a closed switch. So the current is flowing through these devices, through this circuit, through the load circuit, through the load. And here which device is turned on? This T2. T2 is turned on because we have given the gate pulse for T2. And the current is flowing through this circuit, through this path. Positive terminal T1 through the load and T2 negative terminal of the supply voltage. Here the T3, T4 is off condition. T3, T4 is off condition. Here because we have not given any gate pulse. And at the same time, reverse voltage is applied across these devices. That's why T3, T4 off, T1, T2 on. When the T1, T2 is on, the current is flowing through this circuit. The current is flowing through the load circuit. When the current is flowing through the load circuit, the output voltage is present, that is V0 or VL. Output voltage or load voltage is present across the load circuit. So this output voltage wave shape of this output voltage same as the supply voltage. Supply voltage कैसे है, यहाँ से लेकर यहाँ तक ऐसे है ना. This is the wave shape of the supply voltage. So the wave shape of the output voltage same as the like this. It is clear? From alpha to pi. Begin after pi, the supply voltage goes to negative. Supply voltage goes to negative means now this terminal is become a positive and this terminal become a negative. Are you getting the concept? Just get an idea. I'm not going in depth step by step. Clear? Hello? Hello?
Yes, sir.
Okay.
Yes, sir.
When the supply voltage goes to negative, the negative off cycle starts. Clear? From pi to 2 pi. Pi to 2 pi. Oh, the cycle is taken. The total time is taken to complete one full cycle is 2 pi, means 360 degrees. Pi is nothing but 180 degrees. For positive half cycle 180 degrees and negative half cycle is 180 degrees. 180 plus 180, 360 degrees. After 180 degrees, the negative cycle starts, means the polarities will be different. Now the current starts in this direction, positive. Okay. Now we have given the gate pulse for T3 and T4. Now we have given the gate pulse for T3, T4 at this point. Means gate pulse दिया मतलब क्या होता है, ऑन किया अपन इसको, ऑन किया तो ऑन किया तो क्या हो जाएगा, T3 will act as a closed switch and now the current is flowing through this switch. Now the current is flowing through this circuit. Okay, now the current is flowing through this circuit and now कौन सा स्विच के थ्रू जाएगा करंट, T2 और T4, कौन सा स्विच के थ्रू जाएगा,
T4.
T4, because T4 is turned on now, T2 is turned off. T4 is on condition, T2 is on off condition. So now current is flowing through the T4. Now it will act as a closed switch. The current is flowing through this path and through this circuit and through this circuit, negative turn on of the supply voltage. So यहाँ कहाँ से start हो गया, positive turn on of the supply voltage through the T3, through the load circuit. Load circuit का direction same है, देखो लोड सर्किट का करंट डायरेक्शन सेम है, प्रीवियस केस में भी इस केस में भी सेम है, रिवर्स करंट फ्लो नहीं हो रहा है. व्हेन T1 T2 टर्न ऑन, द करंट इज फ्लोइंग इन दिस डायरेक्शन. व्हेन द T3 T4 is turn on, in same direction the current is flowing through the load circuit. There is no changes in the direction of the output current. There is no changes in the direction of the output current, but changes in the direction of the supply current. सप्लाई करंट में स्टार्टिंग में इस डायरेक्शन में करंट फ्लो होता है, नाउ इस डायरेक्शन में करंट फ्लो हो रहा है, सप्लाई चेंजेस. क्लियर, बट लोड करंट इज नॉट चेंजेस. प्लीज गेट इट माय पॉइंट. क्लियर. So when the T3 T4 is turned on, so the current is flowing through the load circuit in this direction. So the voltage is present across the load. So voltage is, the polarities of the voltage same as the previous case, means positive voltage will be appear. So the supply voltage कैसे है, ऐसे है. क्लियर. बट यहाँ पर क्या मिलेगा अपन को, पॉजिटिव मिलेगा. यहाँ पर क्या मिलेगा, पॉजिटिव, बिकॉज This is depends upon the voltage polarity and current direction. Clear? So we are getting the positive voltage here. In positive half cycle supply voltage, we are getting positive pulse. Negative half cycle of the supply voltage, we are getting the positive pulse. Like the same way, cycle is repeated again. Cycle is repeated. T1, T2 is turn on, T3, T4 is turn on. T1, T2 is turn on, and T4 is T3, T4 is turn on, because positive half cycle, negative cycle, positive half cycle, negative half cycle. Cycle is repeated. Means what we can see here, that voltage is not going to negative here. Negative भी present है क्या? No, जीरो के ऊपर present है ना, means what we can say, this is the DC. यहाँ पे क्या दिया अपन, AC दिया है. यहाँ पर क्या मिला अपन को, pulsating DC. Is it clear? DC मिला ना इधर अपन को. Have you got the point? Anyone please?
Yes, sir.
Okay, means just I have explained this circuit, just how the power conversion is going on. Okay, supply is AC, but we are getting the DC here using the converter circuit. Okay, so this is the pulsating DC. So if you want to constant DC like this, so we need to use the filter. We need to use the filter. Whenever we are using the filter, then we can make this pulsating DC into the constant DC. Clear? So this is the simple overall process, how the power conversion is going on from AC to DC. Okay, this is called as rectifier. And next one. Okay, and next one. This is the some derivation I have given. So not important, but just take the formula. V0 is equal to 2 by 2 pi integral alpha 2 pi Vm sin omega t d omega t. This is the basics of the Vs is equal to Vm sin omega t. Supply voltage Vs is equal to Vm sin omega t. We are integrating with respect to supply voltage. Clear? Integral Vm sin omega t d omega t. But here why we are taking the alpha 2 pi? Because the voltage is present, output voltage is present from alpha to pi only. The output voltage is present from alpha to pi. That's why we are taking the limits from alpha to pi. And 2 by 2 pi. 2 क्यों लिखा अपन इधर? 2 क्यों लिखा है? Why we have written the 2 here? Because one full cycle of the supply voltage, we are getting the 2 pulses. We are getting the 2 pulses. Is it right? 2 pulse present in either. Please, anybody say answer?
Yes, sir.
Okay, that's why we have taken the 2 here. And why we have taken the 2 pi here? The time is required to complete the one full cycle of the supply voltage. 2 pi, 360 degrees. We are taking the radians per second. Clear? That is in the form of pi. So this is the 2 by 2 pi integral alpha 2 pi Vm sin omega t d omega t. So 2 will be cancelled. 1 by pi integral alpha 2 pi Vm sin omega t d omega t. So here Vm is the constant. So we are taking outside from the integration part. Vm by pi integral alpha 2 pi sin omega t d omega t. Integral sin omega t d omega t क्या हो जाएगा? We are integrating with respect to omega t. Clear? So integral sin theta is equal to minus cos theta. Is it clear? I think you are well known about the mathematics. सही है? Integral sin theta is equal to minus cos
Yes,
theta.
sir.
Okay, integral sin omega t is equal to minus cos omega t. So upper limits minus lower limit apply करो. Cos upper limit minus cos lower limit. Minus common ले लो. Cos pi minus cos alpha. तो cos pi is equal to minus 1. Minus into minus plus 1. Plus 1 plus 1. Minus into minus plus 1 plus cos alpha. Clear? So Vm by pi into 1 plus cos alpha. Vm by pi into 1 plus cos alpha. For example, if alpha is nothing but firing angle कौन सा है? यहाँ ये वाला. Where we have applied the firing angle, maybe 30 degrees, 0 to 180 degrees है ना, 30 degrees, 45 degrees, 60 degrees, 90 degrees, and so on, etc. Firing alpha is nothing but firing angle, where we apply the gate pulses for the thyristors. Clear? So, for example, alpha is equal to 30 degrees. Alpha is equal to 30 degrees. And supply voltage is equal to 230. Supply voltage is equal to 230. But here Vm, we know the formula Vm is equal to root 2 into Vs, root 2 into Vs, clear? Root 2 into Vs, root 2 into Vs by pi into 1 plus cos 30 into 1 plus cos 30. Can anyone tell what is the value of this one? Root 2 into root 2 by pi into 230 into 1 plus cos 30. Can anyone tell what is the value of this one? Just can anyone tell, please? Okay, for example, we are getting 200 volts. I think not exactly. I'm not calculating. Okay, 200 volts. Clear? If the firing angle is 30 degrees, then we are getting the V0 is equal to 200 volts. Okay, if I increase the firing angle from 30 degrees to 60 degrees, then supply voltage is same. Then we are getting the output voltage V0 is equal to root 2 into 230 by pi into cos 1 plus cos 60. Into 1 plus cos 60 degrees. Okay, this value may be less than 200 volts, maybe 140 volts and so on, etc. You can calculate afterwards. If the firing angle is 30 degrees, we are getting the 200 volts. If we increase the firing angle, we are getting the 140 or 130 volts and so on, etc. Clear? Means what we can conclude this one, if you increase the firing angle, the output voltage will be decreased from like this 200 volts to 140 volts. So means what we can say, did you get the point? And you can calculate personally. Okay, but the output voltage is less than the 200 volts if the firing angle is increased. Okay, so what we can see here, by varying the firing angle here, the output voltage is controlled. The output voltage is controlled. If the voltage is controlled and this voltage is applied to the electrical motor, the speed is also controlled. Is it right or not? Hello? If the voltage is controlled, the speed is also controlled because voltage is directly proportional to the speed. Is it right? Are you get the point?
Yes, sir.
Okay,
Yes, sir.
this is the concept. Just I am giving the idea. इतने डेप्थ में जाने की जरूरत नहीं है. Clear? How the power conversion is going on? AC to DC convert हुआ है, or at the same time we can also control the voltage. Okay, by varying the firing angle. If this load voltage is controlled and this load voltage is given to the motor, okay, load voltage is given to the motor, then the speed is also controlled. Okay, like the same way, yeah, this is the operation is going on the power converter circuit. This is the operation is going on the power converter circuit. Just this is the simple technique, and this is the simple idea I have given for you. Okay, this circuits you are not studying mechanical department. Okay, like the same way DC to AC convert करने क्या है? Inverter. Okay, when T1 T2 is turn on, when the T1 is T2 turn on, the current is flowing through this load circuit. Clear? The positive terminal of the supply voltage T1 through the load through the T2 and negative terminal of the supply voltage. This is the DC. Clear? And the supply, we are getting the voltage across the load circuit because the current is flowing. Because this voltage is same as the supply voltage because supply voltage DC like this. Like this. Okay. And next, when the now T1, T2 off, T1, T2 off. Now T3, T4 turn on. When the T3, T4 turn on, the current is flowing like this. Like this. Now the current is flowing through the load circuit in reverse. So the voltage is also reverse. This is the positive and this is the negative. Okay, minus V0. So now the voltage is present across the load is this one. Means when the T1, T2 is turned on positive, when the T3, T4 is turned on negative, means this is the AC, positive, negative, positive, negative. This is the AC. Like the same way we are getting the DC to AC. This is the conversion is going on the inversion circuit. This is the conversion is going on the inverter circuit. Clear? This is the rectangular AC. If you want to make the sinusoidal waveform, so we need to design some filter circuit. Okay, we need to, if you want to convert this pulse rectangular AC into sinusoidal AC, then we need to convert some filtering circuits. So this additional circuit is required. Clear? This is the power conversion is going on in the inverter. And DC to DC, DC to DC chopper. Supply is also DC and output voltage is also DC. Okay, so time is over, I think. बहुत ज़्यादा हो गया. So I will continue next lecture. Just wait, I will take the attendance. Are you getting bored?
No, sir.
Okay, just wait, I will take the attendance. I think. Okay. This is the role of the power converter. Clear? So थोड़ा सा ज़्यादा डेप्थ एक्सप्लेन किया है.